Okay, so I thought I'd do this video to help my friend Fernando try to duplicate the landing gear effect that I did on my C57D from Polar Lights, and the easiest way was just simply to show him what I had done. Now, what I've got here on the table right now is similar to what is in the ship. This is a 3-channel RC servo tester. It has a little potentiometer that you can sit there and swing the servos with. It also has a homing if you push the button a second time. If you push it the third time, it'll just sweep back and forth. Well, these apparently aren't available anymore, so what I did here isn't going to be relevant for him or anybody else that tries to do this. This uses a little PIC controller. I've added some decoupling and filtering caps, which the board was missing. But the main thing I did was I took the original variable pot off of it and added a resistor and capacitor to the circuit, plus a little test button to allow the servos to move at a slower rate. Here, let me demonstrate. There we go. And I used a little 433 megahertz transmitter receiver that I got off of eBay, really cheap. So if you do order one of these, which the link is in his thread, make sure you ask them if they have the toggled version. Momentary is acceptable, latching is acceptable, but you're going to have to hold the button. This is nice because just one click and you'll see the servos react, and then you push it again, and also the LED controller that handles the landing bay cavities also switch. So we'll push it again and they go back. There you go. So on and off. There we go. On and off. Very simple. I mean, it's the simplest thing I could think of doing other than going the approach that Fernando had done, which he had an Arduino Pro Mini and the Palalu Micro Magesta 6-channel USB servo controller. Both acceptable, I believe, separately or together, but more parts than what I cared to work with, and I like simpler because it's easier. So, anyways, this is what I did, built up one to show him, and then realized, well, not going to be anything he could do. So let's push this aside, and I'll show you what I actually converted, because it's more what he's going to get when he goes to the link that I provided. This is the servo here that's presently available, and let's open this guy up. I'm going to do this real time, so bear with me. Obviously, I'll be doing some editing, so again, don't normally do how-tos, so bear with me. So, here we go. That's the way you're going to see it when you get it. It's close enough. The size is what I was interested in, but more importantly, I was also interested that it would handle 3 servos and the RC switch. I kept these open on my version by actually adding wires for the power aside from the actual pin input that they suggest. Just freed up all those 4, sorry about that, all those 4 pins. I'm reaching around here to get my ground strap because, again, when you're doing this kind of stuff, you really should be grounded. Otherwise, shit's going to fail on you from static. So, this is what I did. It's the newer RC tester, or servo tester. I'll get that right one of these days. And again, like I said, all it took were really, there's 4 components here that I'll be using. The capacitor and resistor, which cap charges, causing the servo to move in one direction. The resistor is what the current charges the cap through. And then I have another resistor in there to bleed off the cap when you either open and close the contacts on your radio, or as I did in here is a little test push button that I put in there so that you can check as you're putting the thing together before you hook up the radio. So let's get out, and this is all running off of 5 volts. So cut the power supply, there we go, it's on. We'll push the button, servos move, LED turns off. That would most likely be the gears retracting, so when you mount these inside your model, make sure you get their arc appropriate for the landing gears travel. Release the button, there you go. So again, it doesn't get simpler. Okay, so first thing we're going to have to do with this guy is get rid of the plastic overwrap so we can gain access to circuit board. So we're going to pull the knob off there, and this is all perforated, so it should be fairly easy. Just start the tear, and it'll just come right apart. A little bit of sticky tape on the bottom, so we'll get rid of that. That's some pretty crappy shit. Leaves quite a residue. So, I'd get rid of it. I have no idea what this chip is. The other one was clearly marked, and it was a small PIC microcontroller. This, let me make sure that, because the one that I did had no markings on it. This also has no markings on it, so I don't know if it's a small custom FPGA that they program or what. Not too sure. So the circuit did change a little bit, and wasn't that big of a deal. So what we first have to do is we got to get rid of the potentiometer that's on there. So let me give you a real quick solder course here. I always have in this little bottle liquid flux. It's rosin flux because I still use lead-based rosin core solder. The industry I'm in requires it, so it's readily available for me. This you can buy, the flux you can buy at a place like Fry's, any local electronics store. You can get it online at places like DigiKey or some of the other electronic tool suppliers. My solder, this is solder wick. This will pull the solder off the board. Be advised, the board is lead-free solder, so what I find really a good thing to do is to feed a little extra solder into the connections to kind of make the temperature a little bit more within the range that I'm working in. I never go above 600 degrees on my iron, ever. If I find that the iron is incapable of handling the task, temperature is not going to help you. It's the wattage you want to increase. If you increase the temperature, you just simply are going to start delaminating the board, or worse yet, have the copper separate from the board. So, now, using the solder wick and pulling the solder away, you can certainly use whatever approach you find more comfortable, but since I've been in the industry over 38 years, certified solderer for all of those years, in whatever standard was appropriate at that time, because it's changed over the years. Today I'm certified 001. solder works really well. Now, unfortunately, these boards, they're disgustingly cheap, so they don't have feed-throughs or vias to deal with, so when you remove the solder, the holes open up fairly easily. But you do want to make sure that you get all the solder off the leads and the pads so that when you pull the leads through, you don't tear up the board. There we go. So that's done. There we go. We've removed the potentiometer, and what we're going to do now is reform the parts to get them ready to fit. Now, one thing I do with this little test switch, which is really intended for surface mount, I bend the one tab down because it's actually going to be placed in the first hole for its anchor. And be careful because it just is almost flush, so it's not going to be the most solid of attachments, but as long as you don't pull on it, you should be fine. Now again, flux is your friend. If you don't have flux in your solder, the solder will not stick. So, and I tend to butter my tip. That's where you go over and you put solder on the tip, and then you come over and let it transfer. So there we go. That's done. The connection is nice and clean. I'm not sure if you can see this very well. Probably not. Okay, once the switch is in, we're going to reform the leads for your capacitor. Now, the value of the capacitor is 15 microfarads, and the voltage is 25 volts. You just need a cap that's above 10 volts because you're driving at 5. I'm using a solid tantalum. Make sure you know which is the positive and which is the negative on tantalums of this particular body style. The positive is the one that's marked on the aluminum electrolytic. It's usually the minus that's marked. So tantalum, it's going to be the positive, and again, it's 15 microfarads. I've reformed the leads, and I'm putting them into the next 2 holes here. And here, let's see if I can actually shape these a little bit more. There we go. And there we go. Okay. Next, what we're going to do is put in the bleeder resistor, which is a 100K. I'm using a axial lead 1/8 watt, and we're going to just bend the lead over like so. And if you use the lead that you just bent over on the far hole, it's going to be contacting the ground. The nice thing about that is we're going to be coming up fairly close to the body of this switch. You should clear it, but even if you don't, it's not going to be a big deal because they're both going to the same potential in the circuit. They're both ground. So if you happen to inadvertently touch that lead to the body of the switch, it's no big deal. It's the same potential. So there we go. We'll push this in. I'm pushing them through the same hole. It's going to be a tight fit. So here we are. And lucky for me, it's not touching the switch body, but it should look like that. Can you see that? I may have to reshoot this. So, now, the next lead, and this I'll use the device because it's going to have to be formed a little bit more. Now, you don't have to be as neat as I am. I tend to like to make my boards as clean as possible, and I also like to have the lead colors going in the same direction. So what we're going to do, bend these leads like so, and to make life simple, we're going to pre-tin the switch contact and the resistor leads so that they go on much nicer. Again, flux is your friend. Pre-tin. The other one I don't care too much about because I'm going to be putting it through the hole. But you get it in here and you want to things pre-fit. So, because we're going to be coming around the switch, we don't want this resistor side touching that switch contact. So, you do want to take the time to form your leads. Alright, that's it. Snip off the leads. Just the 3 pads, nothing else contacting it. And then on the other side, what we've got is got the resistor on the top side of the switch. This is the 47K. I'm sorry, I didn't even mention what value that was. That's a 47K. And it's going from one side of the potentiometer's pad to the plus side of the capacitor. It's what charges the cap. The cap's from ground to the center to the other side of the potentiometer, which that's inside of a chip. Normally that would be the +5, but I don't know what it is in the chip. It's sitting on the scope at 5 volts, but without the equivalent circuit, I'm not sure. But there's your 100K resistor from the center to the other side of the capacitor. So let's add the 2 wires for your power input. Now you see how easy it is to solder when you've got the flux. It just simply, you place it and hit it with a little heat, and you're done. And what you get in the end is just a very nice, shiny connection, which you'll never get with solder that the flux has burned off, which does that almost immediately. Got to figure, got about a half a second at best to get the solder on your connection before the flux is gone. Once it's gone, you're going to end up with a cold solder joint, most likely. So there we go. And now these are kind of close quarters for most people, so you do want to take your time and make sure you don't end up with any shorts, because this is your 5-volt input. There we go. So by doing this, it frees up all of your pins to plug in your servo and your servo switch. So, and I always use nylon lacing to, waxed nylon lacing to hold the twisted pairs together so they don't unravel. Now also, never use a wet sponge. It's miserable. Causes your tip to crack microscopically because of the temperature shock. I always use the dry iron cleaner, and I have some tip cleaner just off camera that I also use to keep my tip in pristine shape. Now I don't have the positive lead here hooked up to my power supply, so it's okay for me to hook it up now because I'll be plugging it in over there. So for right now, we're just going to hook up all of our servos. Signal lead is on the top, just like all standard servos. These servos that I used, by the way, they're 3.7 grams, so they're very lightweight. Alright, so there's all your servos, and now the servo switch. Alright, so now if we did everything right, I should hook up the power and it should zero itself out. There we go, looks fine. Now we'll push the button. Look at that. Just like it should. Alright, now the last connection we're going to do, this is to hook it up to your radio. Okay, so now that we've already proven the circuit functions, we're now going to introduce the radio. We're just going to temporarily tack its power, which it also runs off of 5 volts. So we're just going to temporarily tack these wires together. Alright, and we're going to hook up the channel 1 lead to the top portion of our switch. I only need the one wire because your grounds are all going to be common through the attachment at the battery point. So there's no need to bring a separate ground with you when you make this connection, because the grounds are being terminated through your power hookup. So it's just simply one wire here to hook up. There we go. That's it. Hook our power supplies back up. Again, always make sure you're disconnected from your actual lab supply while you're doing this. There we go. We now have our 433 megahertz radio wired in, and we shall turn on our supply. No smoke, that's always a good sign. Now we'll push channel A, and look at that. Push it again. Don't get no simpler than that. Now I'm going to have close-up pictures of the actual placement of the parts and a schematic. The video is just to kind of give you a real-time depiction of what I'm doing. All this will be found in a link that I'll post in this YouTube text, steering you back to Fernando's thread on his C57D build. Again, this is for the 1/44 scale, I believe it is. It's the smaller version, not the big, huge 3-footer, which really you could do the same thing for it too. So that's it. I be done. Thank you for watching. Bye.